Here we go, Algebra 1, 1-6, relations. So as we get started here, we are going to fill out this chart that's going to be a good reference as we start using the coordinate plane. So this is the coordinate plane. This is where we graph lines and all kinds of different things. We are going to start with this point here. This point is just a random point, but it's just to illustrate how we talk about points. This is point 2, 5. So we go over 2. We do the x-axis first. It's positive, so we go 2 to the right, and then 5 up. So this is the x value always on the left, y value always on the right. This is also called a coordinate pair or an ordered pair. Those are some different names for a point. And this area here is called quadrant 1. Oops, 1. Then let's label all of the quadrants here. So if we go counterclockwise, this is quadrant 2. Quadrant 3. And quadrant 4. Now let's continue here. We got a few more boxes. This line right here, this is called the x-axis. And this one goes left to right. It's the horizontal axis right here. And then this axis, that is the vertical axis, this is the y-axis. Goes up and down. And where the x-axis and the y-axis meet right here, this is called the origin. And that is 0, 0. That's the point at the origin, 0, 0. All right, let's keep on moving. Let's do some definitions. A relation is a set of ordered pairs. The domain of the relation refers to the x coordinates of the relation. The range refers to the y coordinates of the relation. So whenever you see domain, think x. Whenever you see range, think y. Always and forever. Examples. So we're going to state the domain and the range of this relation. So here's a relation, and a lot of times they'll look like this with this crazy deal here, and it has a special name, but I don't remember what it is. And then we have our points listed: -3, 3, 0, -7, 1, -5, and 2, 4, and then we end our set there. So here's our relation. Now this is super easy. We are just stating the domain and the range of this relation, which is just a group of points. So the domain and the range here, the domain, all I'm doing for the domain is writing down the x values. So the one that's on the left of each point, that's my x value. All I'm doing is writing those down: -3, 0, 1, and 2. The range, almost exactly the same, but we're writing down the value on the right of each point, the y value. Range is y, domain is x. We've written down the x values. Now we're going to write down the y values: -3, 0, 1, and 2. And that is your answer. That is the domain and the range of this relation. All right, let's have you do one on your own. here is my relation, -2, -1, -1, 0, 1, -5, and 2, 7. Okay, so you're going to write down the domain and the range of this relation. So go ahead and pause now and get to work. All right, welcome back. Let's see how you did. The domain is the x values of each of these points. So domain is -2, -1, 1, and 2. My range is the y values, -1, 0, -5, and 7. And there you have it. All right, let's keep moving. Representing relations. So let's do some examples of how we represent relations. There are 4 different ways that we are going to be representing relations. One is ordered pairs. We've already looked at that one, but we'll do an example here underneath. But ordered pairs. Another way is a table. We can use a table to represent a relation, a graph, and mapping. So let's do each of these here. So ordered pairs can look like this: 1, 2, -2, 4, and 0, -3. We just have a list of points, or we can do them vertically like we did, or horizontally like we did earlier. Ordered pairs. They can be, vertical or horizontal, doesn't matter. Usually you'll see it horizontal. Table. A table is when we have an X and a Y column. So often we call this a T table because it looks like a T. Surprise. So now in a table, you'll put your X values in this column and your Y corresponding Y values in this column. So when I plug 1 into my equation or into this pair, I would get 2 out. When my domain is -2, then my range is 4. And when my X value is 0, my Y value is -3. So I've just taken these points and I've translated them to be on this table. Now I'm going to graph these points. 1, 2, -2, +4, and 0, -3. So I've plotted these points. I can make them a little bit bigger so they show up. That's another way to represent a relation. Now, mapping. We write domain on the top of the shape on the left, and then we write range over the one on the right. And then we put in our domain values, 1, -2, 0. A lot of times we'll put these in order from least to greatest, so it should maybe be -2, 1, -2, 0, 1, but it's okay. And then we put the range over here, 1, and then we do an arrow to say this 2 belongs to the 1, and this -2 and 4 belong together, and this 0 and -3 belong together. So we draw an arrow here to see who belongs to who. And that is representing relations, and now it's your turn. So we're going to do, so here is your relation. It is 2, 5, -2, 3, 5, -2, and -1, -2. So we are going to write these. You're going to represent this relation as ordered pairs, just below here, and as a table, and as a graph, and mapping. So follow the example that we just did and do the same kind of a deal down here. So you're going to go ahead and pause, and then we'll be right back and I'll work through it with you. Go ahead and pause now. And welcome back. Ordered pairs, I'm just going to list these guys vertically like we did earlier. 2, 5, -2, 3, 5, -2, and -1, -2. So I've listed my ordered pairs. Now I'm going to do a t-table, x and y, put my x values down here and my corresponding y values here. So 2, -2, 5, -1. My y values are 5, 3, -2, and -2. Now, my graph. So I'm just going to take these points and plot them over here. 2, 5, 2, 5. Man, it was nice of some really handsome guy to make this coordinate plane for you with all of these numbers in here. -1, 3, 5, -2, and -1, -2. So there's my graph. And mapping. So I'm going to list the x values and list the y values and draw an arrow. Now this one you may have done, and I'm going to show you a little deal with this particular one. You'll see here in just a second. 2, -2, 5, -1. Those are my x values. That's the domain. And now the range. The range is 5, 3, -2, and -2, but I'm not going to write -2 twice. Why would I do that? All I'm going to do is I'm going to say when I get to -2, 5 goes to -2, and so does -1. They both go to -2. They both have -2, so they belong to one another this way. 2 goes to 5, -2 goes to 3. These two points, these two x values, both have the same y value in common. All right, let's keep going. We're going to skip this independent and dependent variable section, and we're going to go right on to this analyze graphs section. So we're going to do one example and then 2 U-tries. So let's see, we're going to draw a graph, or just this portion of a coordinate plane. The x-axis is going to be time, and the y-axis is going to be distance. And so we have a bike ride. And in this bike ride, we are going to, you are going to get on your bike, you're going to go for a ride, and then you're going to stop at a stoplight, and then you're going to go again. All right, so we're gonna ride, then we're going to stop at a stoplight, then ride again. All right, so let's see what that looks like. So this is your distance from your house. Your y-axis is your distance. Your time is your x-axis. So as you're going forward in time, you're going farther away from your house as well. So as time gets larger, this direction, so does your distance. Your distance gets farther away, that direction. So we go at an angle like this, and then boom, we get stopped at a stoplight. Now, when you get stopped at a stoplight, does time stop? It might feel like it stops, but it doesn't. Time keeps going, but does your distance keep going away from your home? No, it doesn't, because you're stopped. So you're at a stoplight, you're waiting, and then the stoplight bing, changes color, and you get to go again. Boop, like that. So this is where the stoplight happens. All right, let's see how, let's try a couple. Let's see how you guys do with a couple of these here. So we're going to do a drive to school. And, oh, I think we'll just do the drive to school. Yeah, let's do that. All right, so let's think about a drive to school. So again, distance for your y value, or y-axis, and time for your x-axis. So let's say you're driving to school, or your parents driving you, or you're on the bus. Let's say you're on the bus. You're on the bus to school. So we're going to wait till we get on the bus before we start. So boom, you get picked up by the bus. The bus starts going kind of slow and then speeds up. Boom, boom, boom. And then the bus stops again because you got to go pick up some other people. Now at that point, when the bus stops, just like on the one before, what happens when the bus stops? Say it out loud. Let me hear you. Nope. All right. Time keeps going, but your distance doesn't. You wait, you let people get on, then the bus starts going again, goes and goes, and then stops again, another place to pick up some more students. You wait. We're not going any farther, but we are moving forward in time. Wait, wait, wait. Keeps going. And then you get to school. And that is how we might interpret or analyze some graphs. Pay attention to this on the homework. There's different ways you can talk about and think about this, so you might need to be a little creative on that. But I believe in you. Good job. Good luck on the homework.